Now let's look how we can write down the equation of a tangent line at a point using parametric equations. Now, let's do some work before we get there. Using the Leibniz notation, dy dx, you see I can divide both sides by dt, dy dt, dx dt. Do you see that? But dx dt cannot be 0. Okay, so the same way, if I'm looking at the second degree, this is the first derivative of dy dx. You can do the same exact thing. So d dt, d dt, do you see that? And this one is dy dx and dx dt. So you can do the same kind of thing for concavity. Now, I'm going to keep this in mind. So what I need to do is take the derivative of y with respect to t and derivative of x with respect to t and divide them. Alright. Now, let's say I have this situation, x equals t squared minus 2t, y equals t plus 1. When I do the equation, I will find dy dt, the derivative of that, that's 1. And dx dt, the derivative of this one, and that's going to be 2t minus 2. Now, let's look at what happens, and then I just, let's plug in right here, dy dt, so you put 1, and then dx dt, you put that, but this is 2t minus 2. What you need to do is actually go and plug in t for 2, then you will get 2 times 2 minus 2, which is 2. So you have 1 on top and 2 at the bottom, and that is going to give you the slope. Okay? Then when I use the equation of a line, remember how that was? Y minus y1 equals m times x minus x1. That m is going to come from 1/2. And I put that in here. Now let's look at a couple of things. What is x when t is 2? Remember how x was? T is 2. Just put it in here. 2 squared minus 2 times 2. Oh, that gives me 0. So my x1 is 0. And when I put 2 for here, for the y, 2 plus 1, that's 3. I put 3 in here. So my equation of the tangent is y minus 3 equals 1/2 quantity x minus 0. Move that 3 over, so you have y equals 1/2 x plus 3. So when I do it by hand, I get that equation for the tangent. Let's see how I do this using my graphing calculator. First of all, turn off all the stat plots. That is important. If you have some plots, it's going to interfere with what you're doing right now. And let's turn that off. Alright, that's done. And the second thing you need to do, set your calculator in the parametric mode. Let's go and push mode and say, okay, I want it in parametric mode. That's this line. And change that function to PAR, parametric. Push enter. Now you're all set. Now go and enter your x and y. And you go enter that. And when you get that t from this button, when you push it, it will give you automatically t because it's in parametric mode. So t squared minus 2t, you can get the square from this button. And then for y, you have t plus 1. Get the t from this button again. Now, if I want to change my window, I go and I enter negative 10 to 10. And, you know, this is just the default from last time. That's not a bad value. And you can change these things if you want. I'm not going to worry about it. And when you graph, you're going to see your parametric equation. Okay, now, once I have it graphed in there, and I'm looking for the value. Remember, I did it by hand, and I had gotten 1/2. I want to do the same thing using my graphing calculator. There's this feature here that's called Calculate. Push second calculate. It's above the trace. Do you see that dy dx? When you push enter, It's going to give you a bunch of things. You don't quite know where the heck you are. But the t is 2. When you enter 2, oh, it will recognize it. Okay, t equals 2. When you push enter, it gave me dy dx equals 0.5, which is 1/2. Now, I have this graph, and I'm going to go and enter the equation of the tangent line, which used to be this, and I did that in the previous page. Y equals 1/2 x plus 3. Now, go to the equation editor. Now, I'm not in the equation mode, but I'm in the parametric mode. So what I need to do, I can do a little trick. I can set x equals to t, and that way I can enter everything as t, 0.5. Now, at this point, it's going to be t, remember, plus 3. Now, if I graph it, you're going to see your curve, and you're going to see the equation of the tangent line. Beautifully done. Now we are going to look at how we can calculate areas under the curve using parametric equations. Let's go back to the equations. Let's say I have an equation y dx, and I put that y in there without the parametric equations. That's what I used to do. But now let's say t goes from alpha to beta. I cannot use y and dx in here. I need to use t's. So I write down x equals f of t, y equals g of t. And instead of y, I will just simply put g of t. And instead of dx right here, dx is going to be equal to f prime of t dt. Do you see that? And now I have the equation in terms of t. Now, let's see how I can do that in our graphing calculator. Let's say the problem was x equals t squared minus 2t, y equals t plus 1, and I want to see the area under the curve between t equals 4 and t equals 5. Okay, what you can do is just write down what you have. Y equals t plus 1, so that means g of t equals t plus 1. And f of t was t squared minus 2t. Remember, in the formula, I'm supposed to take f prime of t, so I do that, f prime of t, which is 2t minus 2. So t is going to go from 4 to 5, and it's a multiplication of t plus 1 times 2t minus 2 dt. Okay? You can actually go and do that using something under the math. Now, let me show you. You can go math, and if you scroll down, you can use something called function integral. So you can push that, and you can say, well, I'm going to look at this integral, right? So this integral is simply t plus 1. So you enter your whatever the function value is, and make sure that your equation is set in the parametric mode, and the parametric mode can be changed right here under mode, and I have it in parametric mode right here. So you put the parametric mode right here, and then you're going to go out of here with the second quit, and you're going to put t plus 1, right, which is that, times, you have 2t minus 2, 2t minus 2, right? And then that is your function. So you enter the function first, and then you're going to put comma. You're going to put your parameter, which is t in this case, comma, the lower limit, which is 4, comma, upper limit, which is 5. And then you can close the parentheses, and you push, and you're going to get the area. So this is another button that we just learned how to do. Now let's do it another way. Now let's do it with the graph feature. Now the thing is, when I go to calculate menu here, I don't see the integral function in here. It's not built into 84. Maybe in some other calculators it is. I need to overcome that. I know that if I go and I set my mode to function, which is non-parametric, I can actually see when I push the calculate, I can actually see the integral right here. So I want to get to this, so I need to get out of the parametric mode. So I go, okay, well, one way to do that, I can go and do some algebra, pull the t out from here, okay? Add 1 to both sides, take square root and all this, so you get t equals 1 plus square root of x plus 1, and t equals 1 minus square root of x plus 1. But between 4 and 5, it's going to be the positive one, so I already know that. And now y is going to be plus minus. Alright, but now since I'm going back to x and y instead of t, I have to go and get those values. When t is 4, put that 4 in here, I get 8. And when t is 5, when I put that in here, I will get 15. So x changes from 8 to 15. Okay, now the other thing that I need to do, I need to put in my equation. Alright, I can go put that in there. Now let's say y equals, now I got out of the parametric mode, remember? Now I am going to go and put down 2 plus and it's going to be square root of x plus 1. I got that from here, remember? Square root of x plus 1. So let's write this down. So I'm writing y in terms of x, not y in terms of t. And that's going to be 2 plus square root of x plus 1. Okay? Very good. Now, and remember, x has to go from 8 to 15. So I'm I'm on the upper curve. So I'm actually looking for this area, not the lower curve. So I can go and enter that. Now I'm going to go and get the calculate. Second calculate. And I will go and get the integral from right here. So I have the upper curve. I want the upper curve. To see the lower curve, I have to enter the minus 1. But I'm not interested in there. So the lower limit is 8. Do you see where that is? And the upper limit is, what was it? 15. 15. And when you push enter, you actually will go and get the same value, 38.67. It is the same exact value I had before. So there is always more than one way of doing this. And you can try either one, and maybe you can find some other ways of doing it yourself.